I've already told you that the second one follows almost immediately from this connection between the inner product and the weight. So I'm going to leave the full proof of this lemma as a homework question. And that's question 73 on your homework sheets, which I'll be setting you as one of your homeworks in the next week. Okay, so to check whether you've followed what I was saying about the intersection and the weight, I just wanted to give you a quick quiz, just as an anonymous quiz, just as a chance for you to check whether you'd followed everything so far. So if you've got a mobile phone handy, could you take that mobile phone and open a web browser and go to the web address ttpoll.eu. That's written on the slides at the moment if you want to see it. And it should ask you to enter a session ID, and you just need to enter the word Goalie. It doesn't matter whether it's capitalized or not, you can put it in however you like. And note, once you put that in, it will say polling closed because I haven't yet started the polling for the first question. Okay, so your first question then, just as a check that you can remember how to add together vectors, given A1 and A2 as follows on the presentation, what is the weight of A1 plus A2? We can assume VI is V1. Why do I say that's true? Well, let me just switch back momentarily to my presentation. Then here's this picture of the icosahedron that I took before, and I've just chosen two random points, I and J, and I certainly don't have either of them being equal to V1. But I can now rotate this icosahedron, as I'm doing here, until the vertex VI becomes the one that's at the top in the position that we had V1 at before. So I certainly haven't changed the adjacency relationship between those two vertices by doing that, so I might as well just assume that VI was at the top to start with. So I can assume that VI is V1, and now I've still got some rotational freedom left. I can rotate this icosahedron through the axis that joins V1 to V12. It's got a 5-fold rotational symmetry. And that just means I can turn it round like this, so that Vj takes this position down here. And that's the position that we called V7 before. So I can assume that Vi is V1, and Vj is one of V2. Let me rewrite that. V2, V7, or V12. Let me go back to the lemma then that we're trying to show. And let me now fix this page in place so that we can continue with our proof. So if I now